Hi, welcome to Amazing Science TV. My name is Peter Hereza Omar Dennis, and in the earlier videos we were talking about ionization energy. We talked about the factors that affect its magnitude in periodic chemistry. So today we are going to look at its trends. We are now going to look at the trends of ionization energy, and specifically we shall be looking at its trend down across the period. Variation of ionization energy across the period. So that's what we are going to look at today. So ionization energy, we said it's the minimum amount of energy required to remove the most loosely bound electron from the outermost shells of gaseous atoms, neutral gaseous atoms, to form a unipositively charged gaseous ion. So today we looked also at on the factors. Which factors? We talked about atomic radius, nuclear charge, nature of orbitals. We talked about type of the orbital. We talked about screening effect. So those were the factors that we talked about that affect ionization energy. So we are going to see its variation across the period for today, and in the next videos we shall be doing down the group what happens to it. So taking an example of period 2 and period 3. Period 2 has elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluoride, and neon. And group 2, the period 3 also has sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So today, if I'm to look at looking on this period, we see the trend of ionization energy. This Z value, the Z value is representing atomic number. The 3, the 4, those are atomic numbers of the respective elements. So when we check the trend of this ionization energy, we see that the trend, because if you see 520, 899, 800, 01, 801, 1086, 1403, 1310, 1681, 2080, we see the trend generally increases. So the trend of ionization energy increases because we see the same trend here. So the trend of ionization energy increases. The ionization energy increases across the period, that is from left to right. So what would be the reason why ionization energy follows this trend? So the reason as to why ionization energy follows this trend is one. When we check on the factors, taking an example of atomic radius, its trend here, we see that atomic radius across the period, it goes on decreasing. So since atomic radius decreases across the period, and we say that it affects ionization energy, in other words, we said that atomic radius is inversely proportional to ionization energy, in that increase in atomic radius reduces ionization energy, and the reduction in atomic radius increases ionization energy. That's why we see as the molecule, as those atoms go on decreasing in size, the ionization energy also goes on increasing, since they are inversely proportional. Taking also an example of checking on the factor here, nuclear charge. Nuclear charge across the period, as we earlier on talked about it in the previous videos. We say nuclear charge, as nuclear charge increases, ionization energy also increases, in that nuclear charge is directly proportional to ionization energy. Since nuclear charge refers to, we said that it is the attraction of the outermost electrons by the nucleus. So since here when we are checking on this, we see that across the period, screening effect goes on. Screening effect, I think we talked about it as the repulsion force of the inner electrons against those in the outer electrons. So when we check on this, across the period, screening effect goes on decreasing. Why does it decrease? Because the electrons are close across the period. We see one electron is being added. Across the period, and they are being added to the same shells, but the nuclear charge goes on increasing. Nuclear charge goes on increasing across the period. So the increase in nuclear charge outweighs the screening effect, and so the electrons in the outermost shells are pulled more to the nucleus. And in so doing, since they are pulled more to the nucleus, the energy needed to remove the outermost electrons will be too high. That's why we see the trend of ionization energy following this way. It goes on increasing across the period because the size of the atom goes on decreasing. Secondly, the nuclear charge, you have seen it goes on increasing, and so it will outweigh the screening effect, which goes on decreasing. And hence the ionization energy will also go on increasing. So we have abnormalities here. When you check on these trends, we see a 520. This is 899. We expected it to continue raising, but here there is a fall. So what would be the reason for the fall? We check also on the same thing. Here there is an increase. But this increase, when we reach here, we see a fall. The trend, yes, it is increasing, but we see this is an abnormal increase, and this is an abnormal increase. Then when you continue, you see that also neon, there is an abnormal increase. When you also check, like on this, I will first consider the period 2. What could be the reason? The reason is 1. When we write the electronic configuration of this one, we see that when I begin with beryllium has 4. Yes? Beryllium has 4 as atomic number. So we see that the electronic configuration is 1s2 and 2s2. And then when we go to that of nitrogen, nitrogen which has 7, we see that we have 1s2, 2s2, then we have 2p3, isn't it? Then also when you go to this other one, neon which has 10, we see that we have 1s2, 2s2, then we have 2p6, yes, 2p6. So when you check this, the outermost, the electrons are in the orbitals. They are in orbitals that are half filled or fully filled, because we have seen this is a fully filled s orbital, and this one is a half filled p orbital, since the maximum number that the p orbital can have is 6. So we check here that it is half filled. This one, the maximum number it can hold, there are 2. That's why we say this is fully filled, and also here this is fully filled. So since these orbitals, the s and p orbitals, are fully filled, those orbitals are thermodynamically more stable. They are half filled and they're fully filled, and in so doing, since they are thermodynamically more stable, they will require much more energy to be removed for those electrons in those orbitals to be removed. And in so doing, that's why we see there is an abnormal increase here in these atoms where the electrons are in half and fully filled orbitals, which is the same case when you check on phosphorus. I think phosphorus, when you check its configuration, phosphorus that has 15, we see that it is 1s2, 2s2, 2p6, and then 3s2, and then 3p3, isn't it? So with this is half filled, and so it is thermodynamically more stable, and it will require much more energy to be removed. That's why we see the trend here, it has been affected. But generally, across the period, the ionization energy goes on increasing. So, to make a recap of what we have done, ionization energy, its variation across the period goes on increasing because of the decrease in the size of the atoms across the period, and also the increase of nuclear charge across the period, and screening effect goes on decreasing, which makes the effective nuclear charge, since the nuclear charge goes on increasing as screening effect decreases, the effective nuclear charge will be high, and the outermost electrons are pulled more to the nucleus. And in so doing, the size reduces, and the electrons in those outermost shells to be removed, they require much more energy. And that's why we see the ionization energy following that trend going on increasing across the periods. Thank you so much for listening. Reza Amara Dennis is my name. Do not forget to subscribe to my channel, Amazing Science TV, for subsequent uploads. And also hit the notification bell so that you'll be getting the notifications of the uploads. Then also like the video, comment in the comment box. I'll take note of those comments. Then also share the videos with your friends. Thank you so much for listening.